So please consider the following and answer them in the Google form. Crap. The numbering is now going to be off because I asked you something A. Oh, whatever. Here, A is no longer a thing. So here are some student questions in particular, especially about magnetism. And A is no longer a question, but you should still think about it for yourself and see if you can answer this. Also, I encourage you, talk to each other about this. Bounce ideas off to each other. Do magnets have north poles? Okay. What? So these are student questions that I've received, or slightly reworded versions of student questions, and I want everyone to be able to answer for themselves. I think these are core pieces of material. Do magnets have north poles? Is there a north pole of a magnet? Which direction? I think for B, they're asking if that's a compass needle, which direction would that get pulled, so on and so forth. So consider the following, and then I will tell the answers.
No, I'm serious. I'm sorry. I don't get it.
Okay, 1 minute. B through E so far. Although I hope that you can answer the unlettered one as well. Well, there is no F. What are you doing? What is going on? Okay, time's up. Here are my answers. Yes. First off, this was not in Google Forms because there was already an A and I didn't wish to relabel. Yes, magnets have north poles. They also have south poles. That's what we call the ends of a magnet. By the way, magnets cannot be chopped in half to separate the north and south. I don't think I said this before. Did you know this? If you cut a magnet in half, you don't get an isolated north and a south. You can't go out and buy north poles. Did you know that? You get two smaller magnets, each with a north and a south. Hey, I'm curious. To who knows this already? That if you cut a magnet in half, you get two smaller magnets, both with north and south. And who did I just surprise? Okay, smaller number, but still there. I will make sure to incorporate that next semester, next year. So yes, every magnet has a north pole. Question B, which side does the north pole point? I'm assuming that student was thinking about a compass. North poles point north. North poles point north. That is, as I said on slide 1 of this module, how I define the north pole of a magnet. I take a magnet, make it into a compass, see which side points towards Canada. That's what I call the North Pole. I color him red, I draw a little N on him. That is the North Pole of the magnet. This seemed to attract intense confusion on the day of the class, and I believe from the wording of the students' subsequent questions, I do believe that I thoroughly confused them. Let's see, does the North Pole of a magnet face south on a compass? No. The north part of the magnet is the North Pole of a compass. Magnets are compasses, compasses are magnets. When I say North Pole of a magnet, I mean if you let it freely rotate, that will face Canada. South Pole will face Antarctica. Does the red side of a compass actually the south part? No, the red side is the north part. We call it the north part because it's the north part. I define north part of a compass as the red part, as the points north part. Question? So the north side of the Earth, the North Pole, has a magnetic south property to it. That's different from saying the North Pole points south. The North Pole points north geographically. The North Pole points Canada-wards, up, if you will. But what is in Canada is effectively a big south magnetic end of the Earth. Here is a diagram that may help. Red, the convention for red is north. Red is the north side of the magnet. You are here. You are south of Canada. Big X. I put a big honking compass. It's bigger than the state of Arizona proportionally. Big compass. Big compass. The north side of the compass points northward. Now, if the Earth itself were a single bar magnet, wait, are you guys old enough to go to the bar magnet yet? Well, that's where you have alcohol magnets. Okay, if the Earth itself were a gigantic bar magnet, Canada would be located on the blue end, the south end. The south magnetic pole of the Earth is what attracts the north side of compasses. Which side must the south end of the Earth be on? It must be on the Alaska, Canada, Arctic Circle side. What side must the Earth's bar magnet northness be on? That must be in Penguin Land. The Antarctic must have the side of the Earth's magnet that pushes red needles away from it and pulls blue needles towards it. And now again, this is, half a second. This seems to be immensely confusing to a lot of people. I'm not claiming that the north side of the Earth is south. I'm not claiming that the north side of a compass is the south side of the compass. I'm saying that the north side of the compass is pulled towards the north geographic side of the Earth. But since opposites attract, what must be on the north geographic pole is the south end of a big honkin' magnet that is the planet. Jane. Precisely. The Earth is a big honkin', it's actually an electromagnet rather than a bar magnet, but yes, the Earth acts like a gigantic freaking magnet with the north end of the magnet sticking out the bottom of the planet, and the south end of the magnet attracting north sides of compasses up on the top of the planet. Okay, as I was saying, this is really screwing with a bunch of people's minds, so please turn to each other and explain to each other what Jane meant when she said the geographic north is the magnetic south and vice versa. Here's a go. Take 1 second. Minute. Big brain time? At age 6, 5? Awesome. Awesome. Okay, follow questions. Great, let's move on. Shh. What order do V and B go in? Please note, by the way, I strongly encourage you to follow my lead. I never write QBV. I never write BVQ. I never write BQV. I always write QVB. V comes before B in the alphabet, right? Oh, wait, crap. You can't use that rule. Well, maybe if you read backwards because physics is so counterintuitive, V comes before B. I don't know. Write the formula V cross B, QV times B. V is first, and if I say point in the direction of the first vector, what is your default finger to point with? I don't know about every country in the world, but at least in America, we use our fingers to point towards things. If I say point towards the left side of the room, I would think you would point that way. If I said point up, I would think you would point that way. You'd use your fingers to point. So that's the first direction, the V direction, the velocity direction. Which direction is an object, a particle moving? You point with your fingers. And then the second step is we use the second part of our hand. We orient our palm to face in this, that, or the other direction. If I say magnetic field points out of page and velocity is upward. Oh, I'm doing it right now. I'm also taking an oath. No. Velocity upward, magnetic field out of page. I am the magnetic field pushing out of page. Which direction would you say the right-hand rule is saying the force is? To the right is the correct answer. So the answer to D, what I would say is, how do the fingers relate to V and B? Fingers velocity, palm magnetic field, thumb is the direction of the cross product, V cross B. Please note, you can't always say, I shouldn't have said that the thumb is the direction of the force. Because if you have a negative charge, if I multiply a direction by a negative sign, that flips the direction, right? For instance, if I have an upward moving particle in an out-of-page magnetic field, V cross B is to the right. If that charged particle is a positive charge, that feels a force to the right. If that charged particle is a negative charge, I'd say multiply right vector by a negative number, and I get negative right, which is left. Just like last semester, I associate negative up, oh, that's just down. Negative in, that's just out. If I have a negative number, a negative charge multiplying V cross B, the result is flipped from whatever V cross B is. You remember Q, V cross B formula? Great. I had another question, which was, when I said that I'm going to test you on the formula MV over QB, is that on the test? Yes, when I said that that is the one and only thing on the test, I mean that is on the test. And you must be able to plug in numbers and multiply mass times velocity divided by charge times magnetic field to find a radius of curvature. That's what I'm testing on. I reserve the right to switch the letters around. And can you algebraically solve for mass, for instance? Can you put letters in different places? If you can do that, then you can do the one and only question on cyclotron radius, that R. Now I want you to try this again. Everyone hopefully had time for E. I do want to emphasize what I mean by behave. Tell me some properties or the properties that you have learned about voltmeters. Are voltmeters like big resistances or small resistances? Do we put them in series or parallel? Are they prone to breaking? What do they measure? God, I hope that part's easy. Tell me about voltmeters. Tell me about ammeters. Do you know what a switch is electrically? Do you know what short means versus open electrically? I've been using the word short, not just to refer to your mama. I've been using the word short without necessarily having checked to make sure everyone knows what short means. So please, tell me what you think here. And take 1 minute.
Yeah, I'm so like, so stuck.
What? What? Gesundheit. Oh, so good. Okay, 1 minute. Show me what you got. Great. A lot of correcto answers. I love it. Here we go. Here are my answers for E and F. A voltmeter whose symbol is a V is placed in parallel and does not allow current. It is effectively an infinite ohm resistor. From the perspective of current, anyway. An ammeter whose symbol is A measures current, not ohms. Am and ohm are different words. Ohm meters and ammeters are not the same thing. So an ammeter does not measure resistance. An ammeter measures amps, measures current. Ammeters are placed in series. They freely allow electricity to flow. I mean, if you're measuring a current, you shouldn't stop the current. You can't stop the current. Ow! So an ammeter is effectively a wire. An ammeter has no resistance from our perspective. Please.
Like, is it an actual physical thing like a resistor or?
Yeah. Wait, aren't you in the lab section? Haven't you used one? it's a little box you buy with a little setting on the front with the two leads that you plug in that says voltage. Yeah, that's a voltmeter. Oh, yeah, that's a voltmeter. Measures volts. It's a meter which measures volts. Okay, questions about these? I would like you not to memorize, but to understand what current and voltage tell you and get a gut understanding of why these are. Like I was just saying about an ammeter. An ammeter measures current flow, measures current. If you want current to go through it, does it make sense that the ammeter shouldn't block up the current? If the ammeter stopped the current, you wouldn't be measuring the current anymore. You'd be measuring less current than you had. So an ammeter shouldn't have any internal resistance. Ideally, should have zero internal resistance. You don't want to block the current that you're trying to measure. On the contrary, if you're measuring a voltage, if you try to measure a voltage, if current flowed through the voltmeter, then that would disrupt the voltage and current levels that you had before. You would be allowing an alternate path for electricity. All of a sudden, your battery would be supplying not only electricity to run your circuit, but also electricity flowing through the voltmeter instead. We don't want that. If you want to measure voltage, you don't want to change the voltage and current levels within the circuit. So I hope it makes some kind of sense that voltmeter does not want current to flow through it. It has very high internal resistance. We are very good at building voltmeters. 100 million ohms is not impossible with a voltmeter these days. I think that this might be slightly, half a second, might be slightly worth visiting. So we're going to do some examples. And the point is not that I will test you on voltmeters and ammeters. There will be voltmeters and ammeters and measures of voltage and current in the test on Wednesday. But the big thing is if you understand this, you really understand something deeper about current and voltage. So I think spending a little bit of time on this will help with everything, not just the meters themselves. Question? Yes, in parallel. No, they don't break. With an ammeter doesn't block current. An ammeter is free flow current. What happens if you put a redonkulous amount of current in? The ammeter can't protect itself. So you can easily overwhelm an ammeter and blow its fuse. Yeah, I should have put that. Ammeters, subject to fuse blowing. Voltmeters, safe. Let's do some examples. I'm going to change the numbers. How about 24? Okay, Google question I, show me what you think that ammeter will read. Google question J, tell me what you think that voltmeter will read. Use the principles that I just said about voltage and current and their meters. And see if you could figure out what current runs through that top wire, what voltage is across that top right resistor. You may work together. Show me what you got. Did you have a question that I missed? Again, I is the ammeter and J is the voltmeter. That's why I wrote the letters I and J next to them. Yes, when I say in a little box, if I say a letter and say that that's what goes in the Google form, I mean tell me the measure of what do you think the ammeter reads. Google form, here, I will write. Does that make more sense? Yeah? Good. That's the ugliest V I've ever read. You may wish to write that little table up that I just wrote. Voltmeter, big resistance. Ammeter, small resistance. Does not and does allow current respectively. You may wish to write that up and think about that as you're answering these questions. 1 minute.
Let's say a resistor is, then it will read the voltage of that particular resistor, right? On the pull out.
Correct. The voltage lost by that resistor. Voltages in parallel are always the same. If you want the voltmeter to feel that 8 volt, 16 volts, whatever, it better be touching that 16 volts difference. Okay, time's up. 2 and 8. Here's how to think about this. Does the ammeter do jack to the current? No, he allows any current to flow who wants. So this 24-volt battery is connected to this circuit. Does any electricity flow through this voltmeter? No, voltmeters have infinite ohms effectively. Much, much bigger than 4 and 8, I'll tell you that. So current freely flows through here. It does not go this way, it only goes this way. What happens if I have current that flows through a 4 ohm and an 8 ohm resistor in series? What magical formula can I use to deduce the total resistance? Bada bing, bada boom, baby. Total resistance, 12 ohms. If 24 volts is connected to 12 ohms, 2 amps flow, V equals IR. Now, the next part, I got 24 volts, 2 amps leaves it. I've got a 24 volt battery, 2 amps leaves it, and enters the 4 ohm resistor. Well, let me ask you that. This was something that I had a little bit of confusion on. Google question K, if 2 amps leaves the 24 volt battery, how much current enters the 4 ohm resistor? Again, I wish to check how much current enters that 4 ohm resistor. Google question K. Is the current entering the 4 ohm resistor? Yes is not the correct answer. Okay, again, my question is, can you tell me if 2 amps leaves this battery, how much current enters that 4 ohm resistor? And your answer should be measured in amps. If I ask for current, it is in amps, not volts. Okay. The correct answer is if 2 amps leaves the battery, 2 amps flows through the ammeter, 2 amps flows through the 4 ohm resistor. 2 amps, 2 amps, 2 amps, 2 amps. If nothing flows through this voltmeter, we've basically got a series circuit here. Effectively, from the perspective of the current, there's no choices. That voltmeter is not a choice. No current flows through him. Harsh.
Explain the concept where, a single, there are two resistors and there's a middle resistor and it cancels out. That's a concept which you explained in the office hours.
Yes, I could try. Remind me towards the end. We may have to. That's true. V divided by R. V times R. Okay, so tell me, what is the voltage across that resistor? No. This battery supplies 24 volts to this point, but this point is not 0 volts. V is not what is present at one end of the resistor. The meaning of V, and V equals I times R, V divided by R is I, that meaning is the change in voltage from one end to the other. Tell me this, if I hold up a meter stick, and I see, if I just take a meter stick from the ground and hold it up to my face and see the 50 centimeter mark, does that mean that I'm 50 centimeters tall? What's wrong? What have I not done? I've not put the 0 on one end of the meter stick and read my position at the other end. Sure, there could be 24 volts here, but there's not 0 volts here. In fact, this is how I would find how much voltage is on the far side. Use the principle that current is stuff. These 2 amps leaving here are not disappearing, they're not multiplying, they're not spitting off into outer space. If these 2 amps worth of current are going here, they have to go through here. I times R is the change in V. Not just any old voltage divided by the resistance. How do we get the 2 amps? We found the total resistance, because I do know that all of the resistors together are connected to 24 volts. That's how I got 2 amps. Good questions. These are very good questions, very important questions. Okay, so the correct answer, again, for I is 2 amps, exactly as we've done for every compound circuit, always and forever. Find the total resistance. Find the total current leaving the battery. Trace through where it goes. That's how to solve, that's how we have been solving every compound circuit ever. Now, question J. When 2 amps flows through 4 ohms, how much voltage is lost? 2 amps through 4 ohms loses 8 volts. V equals I times R. Now tell me this, if I start with 24 and I lose 8, how much is left? 16. This end of this resistor is at 16 volts. I lost 8 volts passing through here. The difference between 24 and 16 is the V in V equals IR. It is the difference. This point's not at 0, it's at 16. So the difference in voltage is 24 minus 16, or 8. No, you guys don't like that. A lot of blank faces. A lot of blank faces. Do the same process. Do the process we've always done. Find total R. 4 plus 8 is 12. Find total I. 24 volts across 12 ohms, 2 amps. Trace through. Where does that current go? It has to go into that 4 ohm resistor. 2 amps into 4 ohms burns 8 volts. Then those same 2 amps continues on through the 8 ohms, burns another 16. Okie doke. Great. Now let me give you the wrong way of hooking it up. Let's just do one. I will warn you, you must justify your reasoning here, because this is, oh, for God's sake, this is harder than it looks. Be able to explain to each other why it is. Gesundheit. Okay. Are we on K? No, we're on L. Okay, show me what you got. Talk to each other, and reason about it. And think about the meaning of V and V equals IR. All right, so go. You have 3 minutes. It is. As I said, I'm doing it wrong now. What happens? And yes, it's wrong. This is hooked up wrong. This is a voltmeter in series. This is not how you're supposed to do it. Does not explode. Okay, don't tell me how many amps the voltmeter reads. Voltmeters don't read amps, so don't tell me amps. Y'all need hints. Y'all need hints. Okay, here is my hint numero uno. Stop. Pay attention. You're all getting it wrong. Voltmeter has infinite resistance. How much current flows? 0 amps, right? Voltmeters don't let current flow. They have infinite resistance. No current flows. This is in series. Infinity ohms in series kills all current flow, right? If I have 12 volts present here, and V equals IR, wait, what's V equals IR tell you? V is the change in voltage. V and V equals IR is the change in voltage. What's I? What did we just say I is? 0. So what's IR? 0. So if IR is 0, and the meaning of IR is the change in voltage, how much voltage is here? Okay, everyone listen up. I have like 2 people trying and lots of people giving me glazed eyes. Here is how to think of this. Meditate upon this, my grasshoppers, and achieve physics enlightenment. Voltmeter stoppage currentage. No current flows. If no current flows, IR is 0 through this resistor, yes? Okay, IR tells you the change in voltage across something. The change in voltage. If I start at 12 volts here, what is the voltage here? Google question M. IR tells you how much voltage changes across a resistor. This point is at 12 volts. What is this point down here? That is your challenge. What are you talking about? Voltage at the south side of the 4 ohm resistor.
It hasn't gotten to the volt yet. The voltmeter yet killed everything.
If it's in series, the current everywhere is 0. Yeah. Sure. Pick out a piece of paper and write this down. Pick out a piece of paper and write this down, or your notepad or whatever, your iPad or whatever. Question first? Yeah, I'm talking about this circuit. I'm not changing the circuit. Okay, write this down. The top of the resistor has 12 volts voltage. Since IR is 0, the resistor does not change the voltage. The bottom of the resistor has blank volts left. Fill in the blank. If I start at 12 and subtract 0 off of that, how much am I left with? 12 volts! This point is not at 0 volts. This point is at 12 volts. This resistor is utterly doing nothing. There's no current flow. When there's no current flow, there's no energy lost by current flowing through the resistor because there's no current flow. If there's no current flowing through here, no energy is lost by charges in here. So this point must also be at 12 volts. Yeah. That is exactly what I'm saying. If I view this voltmeter as a 100 million ohm resistor, the total resistance is 100 million and 100 million and 12 ohms. Just how much current it flows through 100 million ohms? Nada. Okay, so Google question, how could V equals 12 if 0 amps times infinity ohms? So 0 amps flowing through the voltmeter? No. 0 amps flows through the, well, 0 amps flows through everything, sure. But the voltage lost across the 4 ohm resistor is 0 because current is basically freaking 0. Now, I don't think that's what you're asking, though. I think the person posting, how could V equals 12 at the top of 0 amps times infinity ohms? Well, the infinity ohms here, it's not actually infinite. It's actually like 100 million. Okay? So the answer, Richard, dollars to donuts, what you're asking. The current is not actually 0, 0, 0, 0, 0, 0, 0, 0. It's 0.0001. If you put 100 million ohms in place, I can solve the current. I equals V over R. Basically, R is 100 million. So voltage is 12 100 millionths. Okay, now it's not 0 current. It's stupidly small. This much current times this much voltage is 0. 48 over 100 million. Who cares? It's 0. No voltage is lost in that. But the voltmeter itself does read 12. Why? If we treat this as a 100 million ohm resistor, the current of 12 100 millionths times the resistance of 100 million is, well, let's work this out. 12 100 millionths times 100 million is 12. The voltage dropped across the thing which is stopping the voltage is the 12 volts. Yeah.
Think that for a voltmeter, something.
Ooh. Teacher in trouble. Yeah.
Saying that for a voltmeter to read something.
Oh, this reads something.
Yeah. Doesn't
Reads
need
12.
doesn't need pass.
No, current can't pass through it. I mean, nano amps in this case, but. Okay, so the correct answer for, what did I ask? When did I ask it? L is 12. If the voltmeter stops up current, no energy is lost in the resistors. If no energy is lost in the resistors, this point is effectively at 12 volts of voltage. It's effectively the top side of the battery. If this point is not, if this resistor has no current in it, no voltage is being dropped there. So this point is effectively the bottom terminal of the battery. This voltmeter just reads the battery directly. Question me. I don't feel like that makes sense to y'all. And that is showing me that you don't understand what V equals IR is actually telling you, which is important. You think you get it? Well, let's test it. Here's a similar problem. Instead of 24 and 8 and 6, oh, those are hard numbers. How about everything is 1? 1 ohm, 1 volt, 1 ohm, 1 ohm, 1 ohm. I have a battery with a series 1 ohm resistor, and then this splits, but I put a voltmeter in the wrong position. If I put a voltmeter here, I challenge you, figure out what that voltmeter reads. This is Google question N. See if you can solve this. You got to think about it. Turn to each other, help each other out. This is not something you can guess. No current flows here. You might as well ignore this for a minute. Hint, if no current flows through the middle branch, whoopsie, no, I don't want that mode. If no current flows through the middle branch, can you tell me what would the voltage and currents be in this circuit? What would be going on in this circuit? So what would happen? What would the voltage be at the midpoint of those resistors? No, no. There'd be voltage present here. We don't like it. It does. No current flows through that meter. That doesn't mean the voltage is zero. You can have voltage without having current. No. What's the voltage that's present here in this circuit? 1/1? Hmm? Yes. Good. Do that.
One question. So the first resistor, 1 ohm, is in the series. So as we know that
With what? Be precise. Is in series with what?
the combination of
Yes.
second and
Good.
so I'm saying like, let's say, as we know that in series the voltage split, it respectively split.
Good.
Yeah. So when we get total voltage, and then in the first one it will like use some voltage, and the leftover voltage will go forward, and then it won't split, but because it's parallel, second and third. So the voltage sends the leftover voltage.
Good. That's exactly right. You got it. You got it. It's clicking. Okay, ready? My big hint is, look at this circuit. If no current can flow through the voltmeter in series, you might as well cut that part out for a second to think about this. All right, what do I do if I got two resistors in a circuit? Find the total. What's the total of 1 and 1? What's the current that flows? Half an amp. Half an amp leaves this battery. How much current goes through this resistor? Half an amp. When half an amp flows through 1 ohm, how much voltage is lost? V equals IR. What's half times 1? Half, 0.5. Okay. If I start with 1 volt and I subtract half a volt, how much is left? Okay, so this point is at a half a volt potential, right? Now, I'm going to add this resistor back in. This resistor and voltmeter. If this voltmeter is not allowing any current to go through, does that disrupt any electrical flow that was there before? No. There's still going to be half an amp flowing through here. Still dropping half a volt here, the other half a volt here. Nothing is flowing through here, right? Tell me this. If no current flows through here, how much voltage changes here? I'm sorry, if no current flows through here, how much does this change the voltage? It doesn't. V equals IR. I is 0 in this resistor, so the change in voltage is 0. Half a second. If this point's at half and this doesn't change, what do you get if you start with half and don't change? Half a volt. Correct answer was half a volt. Question, please. At this point? Sure, absolutely. What's my total resistance? Yeah. Yeah, right? What's my total resistance now? Nope. Still 2. This blocks all current flow. No current flows through here, so this isn't part of the circuit. You might as well cut this out. Okay, so this is still 2 ohms, right? How much current flows when 1 volt pushes on 2 ohms? 1 volt pushes on 2 ohms, drives half an amp. Great, half an amp, 1 ohm. How much does this lose? How much voltage drops here if I've got half an amp and 1 ohm here? Exactly, half a volt. I start with 1 volt. I lose half a volt in this resistor. I've got half a volt left. Yeah? Clicky? Good. This is huge. There will be a question with meters on the midterm, but what I'm seeing here, this is worth spending the time for me and for you, I think, because I'm seeing a big misconception about what V equals IR means, and that's on like 15 different problems. So please do think carefully about this. Yes. It was. We'll compare these two circuits. Here, there's only one circuit. Here, this is series. There's only one circuit. Here, there could still be flow because this is not a series circuit. Yeah, a voltmeter blocks current through it, not magically through everything. Voltmeter only touches what it touches. Voltmeter doesn't allow current through it. That doesn't mean that it can magically affect everything. Please. Half of a volt left, that's right. Okay. That's right. If I subtract the remaining half a volt, I'm down at 0 volts potential, which is I'm at the battery to be recharged again, to be re-energized again. It's exactly how it works. Well, I said that, are you okay with half an amp flowing? Really? You sure? So you're okay with half an amp flowing. That's the first principal step, okay? Then V equals IR tells us what? Half an amp I, 1 ohm R tells us what? If I say V equals I times R, V, oh, for dog's sake. V equals IR. If I've got 1/2 of an amp in 1 ohm, I've got 1/2 of a volt lost in that resistor. This guy changes the voltage by 1/2. If I start with 1, subtract 1/2, I've got 1/2 a volt left at that point. Now, if I have this 1/2 a volt present at this point, and my 1/2 an amp is continuing to flow along, 1/2 an amp flows through this resistor. It can't flow through this resistor. That resistor's got a voltmeter after it. So that 1/2 an amp only flows through this resistor. Tell me, 1/2 an amp times 1 ohm tells you how many volts? No, 1/2 times 1 is not 0. Yeah, V equals IR again. If I have I is 1/2 and R is 1, the voltage lost here is 1/2. Okay, now I start with 1/2. I subtract 1/2. How much is left for the bottom? 0 volts left at the bottom. But that's the whole point of the battery. I'm left with 0 volts at its bottom. It pushes the charge where it doesn't want to go. It takes disenergized charge and pressurizes it back up to 1 volt potential energy per coulomb of charge. And it repeats. That's what a battery does. Thank you for asking. One more. One more. Harsh had a proposal. So far, so good? Yeah? Dun, dun, dun. This is what you wanted to see, yeah? Great. Let's do it. As always, I don't believe you just learned by seeing. Do it. Try it. Start it. Think about it. I will present the answer in like 1 minute. Get as far as you can. Twenty. Midterm, 20 questions. Well, I mean, what I just said is specifically with meters drawn, 1 or 2 questions, but the principles, the people that are making people struggle with it, like 10 questions. Principles of series and current, the meaning of V when I say V equals IR, that's where people are screwing up. They're not screwing up with the meter symbol. Give it a shot, give it a shot, give it a shot. You don't learn nada by just osmosis. Hey. What? Tell me in O. Tell me your best guess in O. How much current flows through that ammeter? Do you know this, Sahir? Can you do this? What do you see in your head? It's called a bridge circuit, by the way. True. It could. Does it? That's true. That's true. That's true. What is the current in the circuit? Hold on, now I have to do math. Yes, correct. 4 amps flows. Then? Hmm? That's not in series with where those amps flow. Good, I'm glad I've got something that you can learn from. Good, Harsh.
Is that a true question?
Yeah, tell me in O what you think that ammeter is going to read. Okay, time's up. Give me your best shot. Okay, so here's how I analyze this. Ready? Ammeter is a wire. So basically I've got 2 parallel 4 up here. You see that these are parallel? 2 parallel 4 down here, right? 3 and 3. 3 plus 3 is 6 total, right? That parallel in series with that parallel is 6 total ohms. I see 3 amps leaves the circuit. Well, 3 amps flows through these guys. Yeah, then the 3 amps continues to flow down through here. Wait, but this side versus this side, I'd say if I've got a 1:2 resistance ratio, 2 amps are going to flow through here. 1 amp is going to flow through here in that parallel, right? Do you see that in your mind's eye? You got a 2-to-1 current ratio? Do you believe me that 3 amps flows in the total circuit? 3 amps goes and it'll split here. 1:2 resistance ratio, 2-to-1 current ratio. You get 2 amps here, 1 amp here. All right, well, ask yourself this. When 2 amps flows through 2 ohms, how much voltage is lost? 4 volts? When, sorry, what is it? 4 amps flows. God, what did I just say? 2 amps flows through this 2 ohm, 1 amp flows through the 4 ohm. Either way, you lose 4 volts of voltage. So the voltage at this point, the voltage at this point is equal. Why would anything flow along this wire at all? There's no imbalance. There's no imbalance. If you cut this wire, this point is at half the battery voltage, this point is at half the battery voltage, right? Do you see that in your mind's eye? Cut this wire in your mind's eye. Look, what happens when I've got 2 resistors of equal value? They split the voltage 50-50. 2 resistors in series, voltage splits 50-50. This point will be at 12 volts, half of the battery. This point will be at 12 volts, half of the battery. Now I connect these with an ammeter. 12 volts and 12 volts drives no current, even through 0 ohms. Correct answer is nothing flows through the ammeter by symmetry. Harsh, what you thinking?
Now, when the 4 ohm resistor, we see that there is no resistor in the emitter.
Wait, hold on. It's time. You could stay around and ask, but it's the end of class. I'll see you on Wednesday. Bring your Scantrons. Bye.